Welcome to this demonstration of a HIM Pro interface, showcasing the interaction between Engineering Base and CATIA V5 or V6 for wire harness design. We start by opening the KBL file, which contains all the data related to the harness design, including the structure and electrical properties. Here, we can see a skeleton view of a harness, as generated by Engineering Base. This view provides an overview of the design before synchronization with a 3D model. When synchronizing the HIM Pro, it will compare the lengths, diameters, bend radius, and designations of the harness branches and its components. If there are differences between the model and Engineering Base, we will see it highlighted in the skeleton view and in the table. Next, we synchronize the bundle diameters that were calculated in Engineering Base with the CATIA model to ensure the correct sizing is reflected. Once synchronization is complete, the interface highlights the branches in green, indicating that the data from Engineering Base has been successfully applied to the 3D model. We now synchronize all the diameters in the harness to ensure the entire model is updated consistently with the data from Engineering Base. At this point, splices that were added in Engineering Base are visible, but they are not yet represented in the 3D model. We will now proceed to correct that. If no specific position for the splice was provided in the initial design, we can place it within the 3D model according to the mechanical constraints of the assembly. In this case, however, Engineering Base already specifies a preferred splice location, which is 50 mm from the breakout. We will follow this guide and position the splice accordingly. Now, we place the splice on the correct segment and ensure that it is exactly 50 mm from the breakout, as defined in the Engineering Base data. Let's go ahead and position the splice near the harness bundle. We then select the exact location that has been predefined on the branch. For the second splice, we can simply copy the first splice model and paste it in the new location, saving time and ensuring consistency. For now, we will place the second splice near the preferred location in the model, ready for final adjustment. Now, as with the first splice, we'll designate the exact location for the second splice on the branch. With the splices in place, we refresh the logic and compare the 3D model with the data model. This allows us to confirm that the splices are correctly represented in both structures. We notice that the names of the splices in the 3D model don't match the data model. We will now reassign the correct names, which can be easily done by a simple drag-and-drop operation. In the data model, we see that while the branches now match, the segment names between CATIA and Engineering Base are still different. We will synchronize these next, as well as update the bundle diameters once the two are associated. When the two are synchronized, we will see the segments highlighted in green. We repeat the synchronization process for the last segment to ensure all data between the two systems is consistent. Once we have completed the synchronization, we can be sure that our 3D model accurately reflects the Engineering Base calculations. If adjustments are made within the 3D model, we can also now transfer these changes to Engineering Base as well and see the changes reflected in our drawing, ensuring that our design is always in sync. Breeden Wiring Systems is your North American sales partner for Engineering Base. To learn more, visit our webpage at bwswire.com or send us an email to get started.